Welcome to Learn with AI. Today we're exploring the powerful quadratic formula. Get ready to discover how this essential tool solves any quadratic equation and reveals the secrets of parabolic curves. A quadratic equation is any equation in the form ax squared plus bx plus c equals 0, where a is not 0. If it were 0, we'd have a linear equation instead. The graph of a quadratic is always a parabola, that distinctive U-shaped curve. Let's examine parabola characteristics. The vertex is the highest or lowest point. The axis of symmetry is a vertical line through the vertex. The roots or zeros are where the parabola crosses the x-axis, and the direction depends on whether it is positive or negative. The quadratic formula finds the roots of any quadratic equation. The coefficients a, b, and c come directly from the standard form. The plus or minus symbol means we can have two solutions. This formula works for all quadratic equations. The discriminant, b squared minus 4ac, tells us about the nature of the roots. If it's positive, we have two real roots. If it's 0, we have one repeated real root. And if it's negative, we have two complex conjugate roots. Let's solve a quick example x squared minus 5x plus 6 equals 0. Here, a equals 1, b equals negative 5, and c equals 6. Plugging into the formula gives us x equals 5 plus or minus the square root of 25 minus 24 all over 2. This simplifies to x equals 3 and x equals 2. Let's break down the step-by-step solution process. First, identify the coefficients. Then calculate the discriminant. Next, apply the formula. Simplify the expression. Finally, write the two solutions. This systematic approach ensures accuracy. Time for a challenge problem. Solve 2x squared plus 7x minus 15 equals 0. With a equals 2, b equals 7, and c equals negative 15, we get x equals negative 7 plus, or minus the square root of 49 plus 120 all over 4. Can you find the solutions? Quadratic equations appear everywhere in real life. In physics, they describe projectile motion. Engineers use them for structural design. Financial analysts apply them to maximize profit. And computer graphics rely on them for smooth curve modeling. In physics, we use the quadratic formula for projectile motion. The equation ht equals dash 16t superscript 2 plus vt plus h describes height over time. To find when an object hits the ground, we set ht equals 0 and solve using our formula. Engineers use quadratic equations for bridge design optimization. They calculate maximum load capacity and stress distributions. The parabolic shape provides optimal strength-to-weight ratios for suspension bridges and arch structures. In finance, we use quadratic equations for profit maximization. The equation Px equals dash 2x superscript 2 plus 100x, 500 models profit based on price. Finding the vertex gives us the price that maximizes profit using our quadratic techniques. Let's explore the derivation process. The quadratic formula comes from completing the square on the general quadratic equation. Starting with x superscript 2 plus bx plus c equals 0, we systematically transform it to isolate x, resulting in our powerful formula. Completing the square is the method behind the formula. We transform x superscript 2 plus bx plus c equals 0 into a, x, h superscript 2 plus k equals 0 form. This geometric approach shows why the formula works and provides insight into the parabola structure. Factoring is an alternative method when possible. For x superscript 2, 5x plus 6 is equal to 0, we factor to get x 2x 3 equals 0. This gives us x equals 2 and x equals 3. While faster when applicable, the quadratic formula works for all cases. The graphical method involves plotting the parabola and finding x-intercepts. This visual approach is useful for estimation and verification. Modern calculators and software can plot these curves instantly for quick solutions. The discriminant analysis shows how B superscript 2 for AC affects root nature. Positive discriminants give 2 real roots. Zero discriminants give 1 repeated real root. Negative discriminants give 2 complex conjugate roots. This classification is crucial for understanding solutions. Coefficient effects show how A, B, and C change the parabola. The coefficient controls opening direction and width. The coefficient B affects horizontal position, and C controls vertical position. Changing these transforms the entire curve. Avoid these common mistakes when using the quadratic formula. Pay attention to negative signs, especially with the B term and dash 4AC. Don't forget that the plus or minus symbol gives you 2 solutions. And always double-check your discriminant calculation and arithmetic. Always verify your solutions by substituting back into the original equation. Use a calculator for complex calculations to avoid arithmetic errors, and graph to verify intercepts visually. These verification methods catch mistakes and build confidence. Beyond basic quadratic formula applications, we explore advanced concepts. Complex number solutions occur when the discriminant is negative. Quadratic inequalities solve for ranges rather than exact values. And systems of quadratic equations find intersection points. When the discriminant is negative, solutions are complex numbers. We write x equals negative b plus or minus I times the square root of the absolute value of b squared minus 4ac all over 2a. For example, x superscript 2 plus 4 is equal to 0 gives x equals plus or minus 2i. Quadratic inequalities solve for ranges x superscript 2 plus bx plus c greater than 0 or x superscript 2 plus bx plus c less than 0. We use the roots to determine sign intervals. Testing points in each interval tells us where the inequality holds. This is crucial for optimization problems. Systems of equations involve solving simultaneously. For example, y equals x superscript 2 plus bx plus c and y equals mx plus d. Setting them equal gives x superscript 2 plus bx plus c equals mx plus d, which we rearrange to standard form and solve with our quadratic techniques. Let's recap our key takeaways. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It solves any quadratic equation in standard form. The discriminant tells us whether we'll have real or complex roots. And remember to always verify your solutions. Thanks for learning with AI.